Hello and welcome to the Day 1 notes for Integrated Math 2. Today we're going to be looking at some exponent properties. Okay? And we did these in class, I know, but in case you forgot, or in case you didn't write something down, or you did some of the other problems on the notes here and wanted to see how you did, that's why this video is coming out, to help you and maybe to answer any of your questions, or at least give you a place where you can answer questions. Feel free to leave it in the comments down below. So today we're talking about exponent properties. What do exponents mean? Okay, I think that's kind of one of the most important things, and we should understand that, is that exponents mean repeated multiplication. Make sure we spell things correctly, which is amazing, because we look at so many different things in math, and so many things we have shorthands for repeated something. Multiplication. Well, what is multiplication? Hopefully you learned in another class that multiplication is just repeated addition. So we're stepping our game up another level. Instead of just multiplication being repeated addition, well, now we're like repeated addition. That's an amazing idea there. And so what we're going to work on today is just to be able to write some of these things with exponents, without exponents, see how things kind of simplify if they do, and we're just going to look at that. So that's kind of nice. So repeated multiplication, that's what it means. So 2 to the 5th power, 2 to the 5th power means I have 2 5 times. So I have 5 2's here. Okay? And so that means that's 2 to the 5th power right there. That's what it looks like. Now, of course, you can figure out what that is as just one number. Feel free. I'm not too picky there. But eventually, you're going to get to some of these powers are going to be something wicked here as far as what kind of number it's going to give you if you just tried to, evaluate that exponent. For instance, if I look at let me try to find my calculator here. If I look at, let's say, 2 to the 100th power, okay, that's an amazingly large number. Okay, that's I don't even want to guess what the name would be, because I know to about here, maybe here or here, I guess. But look at how big that number's getting. That's an amazingly large number. And then if I get much bigger, and remember, this is only with a 2. Think if I would have put a bigger number as the base there, and just even right there, that gives me this weird notation, this scientific notation, if you've heard of that before, where it's not, the answer is not 1.07. That's not my answer. This e to the plus 300 means move the decimal 301 times to the right, and that's what you would get. So there's like 302 digits in this value. So just to give you an idea of that, and it wouldn't take much more for just this calculator just say, you know what, I'm done. I can't take it anymore. I can't compute that big of a number. Like I said, it wouldn't take much. Okay, and it tells me overflow. So it's exceeded the realm of what the calculator can do. So we want to be able to write these things with these exponents and not always have to have a number answer. That's not what I'm always looking for. So I want to kind of practice that. So if I look at 2/3 to the 4th power, it's going to be 2/3 written down 4 times with multiplication in between. And trust me, I would not want to. I think that last one was that I put into the calculator was like 2 to the 100,000 or something like that, and I definitely wouldn't want to write down 2 100,000 times either. So I don't think I'm asking you to do that, but we're going to use this expanding and condensing of these exponents to kind of help ourselves out to understand what the rules are. That's our goal with these problems here. -5 to the 3rd power. Well, -5, so that just means I write -5 3 times. Excuse me. right? And I mean, there is an advantage to doing this because I could probably more easily figure this out. I know that 5 times 5 is 25, and a negative times a negative is a positive. So I know that this is going to give me, 25. And then I can multiply by -5, and that would give me my answer. Ends up that it's -125, but I didn't ask you for that. Don't get focused on that. I get a lot of students that are always, they think that their answer has to be one thing. I'm asking for your answer to look something like this. So go ahead and pause the video and give those bottom 3 problems a try. Okay, hopefully you had a chance to do those. What we come up with is 3 times 3 times 3, x, 2 5s, 3 x's and 6 y's, 3 -4s, 5 m's and 2 n's. Sorry, they got a little sloppy there. Writing m's and n's can be a little tricky on a mouse, so good luck to you. Anyways, moving on, we are now talking about condensing. So now I want to take what has started out as something that looks like what I just did in the previous section, and I want to undo that. I want to now write them with exponents. So I look here, well, how many 2's do I have here? I have 1, 2, 3, 4, 5, 6. There's 6 2's, so that's going to be equal to 2 to the 6th. This next one, I have -3. It's a good idea to put your negative numbers in parentheses when you have them. -3 3 times, so it's going to be -3 to the 3rd. I'm not happy with that. Let's get a little happier. There we go. And then over here I have 5 4 times, so I can write that as 5 to the 4th. And there's 3 of them, so x to the 3rd. Okay, go ahead and pause the video again and give the last 3 a shot. All right, for this one, I started with the 2/5. Now, I will make a note, or I will say real quick that you really want to write parentheses around your fractions as well. I know I said it for negative numbers, but if I had 2/5, and I know that there's 5 of them here, but if I write it like this, 2/5 to the 5th, that could be misread pretty easily. Somebody could think that that means 2 to the 5th over 5. So I do like to have parentheses around those. It's good conventions, if you will. So I don't really like that idea. That's not the best idea. So put parentheses around it. So we have 2/5 to the 5th, b to the 3rd. For the next one, I have 6 to the 3rd, a to the 4th, b to the 3rd. And the last one, I have -7 to the 4th, x to the 2nd, and y. Okay, there's a y there. I put it as y to the 1st. And that's okay. There's one y there. It's just y to the 1st. In fact, anytime we just have a number or a variable, and there's just one of them, and this is something that we, don't really deal with too much. But anytime there's just a number or just one variable, there is a 1 there. Okay, we have to understand that there is a 1 there. All right. Now I want to explore these 3 different rules that we have for exponents by expanding these, writing them without exponents, and then condensing them back down. That's what I want to look at doing here. So on this one, I'm going to just narrow this up a little bit so I have a little bit more room. I have 2 to the 3rd and 2 to the 6th. Now, sadly, that means I'm writing 2 a bunch of times. And just for looks, I'm going to put each one of these in parentheses. Not that it's really needed. That one got a lot bigger. 4, 5, and 6. Now, I know they're in parentheses, but they don't really have to be. Okay, in fact, I could get rid of these inside 2 parentheses and the outside ones as well, but that's just a little bit more work. When I wrote those 2 parentheses next to each other, what was happening in the middle? It was multiplication. So now I just have a longer string of 2's where I had 2 shorter strings of 2's. Now I just got one longer one. And how many 2's are in there? There's 9 of them. So it becomes 2 to the 9th. Okay, well maybe we're starting to see something there. There's 2 there, 2 there, 2 there, and 3, 6, 9. Maybe it's just going up by 3 every time. Let's continue. Let's do the next one and see what I get. Actually, I'm gonna drop the parentheses on this just to make it a little bit easier, a little bit less writing. So I have 1/2 twice for the first one. And then what's going on in between here? Again, I have 2 parentheses next to each other. That means multiplication. And then I have 1/2 4 more times. So times 1/2 times 1/2 times 1/2. So there we go. Now I've got the 1/2 squared and the 1/2 to the 4th. So that being said, how many 1/2s do I have here? I have 6 of them. So I could write that as 1/2 to the 6th. Are we starting to see an idea of what happens here? So here I had my a 2, a 2, a 2, and then 3, 6, 9. Here I have 1/2, 1/2, 1/2, 2, 4, 6. Oh, yeah. Well, that one it went up by 3 every time. This one it went up by 2 every time. I don't know. Let's look at one more. I'm going to stick with parentheses on this one because it is a negative number. And if I try to write multiplication without parentheses with a negative number, it starts to look like subtraction. So I have the first negative 10 being multiplied by negative 10 to the 3rd power. So negative 10, and then negative 10, negative 10, negative 10. So how many negative 10s do I have? Well, I have 4 of them. So that looks like negative 10 to the 4th. Well, again, I have negative 10, and negative 10 right here. And then nothing there, 3 there, and 4 there. Oh, but wait, we said that anytime we just have a number by itself, it's actually a 1. Oh, see, I see what's going on here. So now we have 3 plus 6 is 9, 2 plus 4 is 6, and 1 plus 3 is 4. Okay, so all I do is I rewrite my base number, my bigger number, the number that's being raised to the power, and I add my exponents. Go ahead and give those a try on these problems right down here. All right, hopefully you had a chance to do that, and hopefully you see something that, this is the way that I write it, I guess. You don't have to write it this way, but it's a pretty conventional way to write it. That's pretty nice. So I know that I have the same number down here, b, whatever b might end up being. 3 plus 7 is 10, so I'm going to have b to the 10th. And that would be my simplified answer. And that's a lot more simple than what that looks like. Over here I have 2 to the 2nd, 2 squared, and 2 to the 4th. 2 plus 4 is 6. And then I have x to the 7th and x to the 6th. 7 plus 6 is 13. And so that would be my answer there. 2 to the 6th, x to the 13th. Here I have 4 plus, well, there wasn't really a number here, but I had to remember that any number without an exponent can just be seen as that number with a 1 as the exponent. So I get 3 to the 4 plus 1, which is 5. So 3 to the 5th power. D to the 2 plus 3, which is also the 5th power. So the product rule for exponents really just says that if I have any number to the n times any number to the m, note that these two have to be the same number. But if I'm multiplying, here's the key here, is this multiplication, then I would add the exponents. So n plus m would go in the exponent there. Cool, got one down. Let's look at the next one. So this one's called the power rule. And this one, gets a little bit cumbersome, I would say. Let's expand this, and then we'll condense it back down afterwards. So if I expand 4 to the 3rd, and I'm going to leave that the outside squared alone. I'm just going to focus inside the parentheses, you know, following an order of operations and all. So 4 to the third, and then I'm going to square that. So squaring means multiply by itself, you know, second power, multiply by itself. So it's going to be 4 times 4 times 4 times 4 times 4 times 4. Right. How many 4s do I have now? 1, 2, 3, 4, 5, 6. So it's 4 to the 6th. Somehow 4, 3, and 2 became 4 to the 6th. Let's look at the next one, see if we can make any headway on this. So the next one is 2 to the 4th, which is 2 4 times, as painful as that is. I'm going to do a little bit of, oh, not that quick work. Let's go ahead and lock that. Now I should be able to do this. I kind of bleed over into the other problem a little bit, but that's all right. So that's what 2 to the 4th to the 3rd means. I have 2 to the 4th written 3 different times. Okay, well, what is that going to give me? Well, how many 2's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to give me 2 to the 12th. So again, somehow that, well, we notice that 2 stayed there. And 4 and 3, well, how do 4 and 3 come together and give you 12? Oh, 4 times 3. Okay, and that ends up being 3 times 2 gives me 6. Let's see if that works out on this one. So I have x to the 5th squared. So I'm going to kind of use my little trick again, but I do have to write the first one. 5 x's. Those are all being multiplied. Ugly parentheses there. I'm not going to let it bug me. I'm not. I won't let it. I won't let it do it. All right. So I have x to the 5th. So 5 x's written twice for that squared. So how many x's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have x to the 10th. Okay. Well, that seems all right because 5 times 2 is 10. So when I have a power raised to a power, I multiply the powers. So my power rule for exponents, if I have any number that's raised to the n power, and then the whole thing is raised to the m power, we would write that as that number to the n times m. Go ahead and use that idea to finish those other 2 problems. Okay, hopefully you had a chance to do those. So I see that on the first one, it's 2 to the 2 times 5. One thing I didn't really say, I kind of tried to trick you a little bit, is you do kind of have to distribute these exponents on the outside. You kind of have to distribute them and then apply this rule. So 2 to the 2 times 5 is going to be 2 to the 10th. And x to the 3 times 5 will be the 15th. Okay. The next one, I have 5 to the 2 times 3, which is 6. X to the 3 times 3, which is 9. And y to the 5 times 3, which is 15. Okay. So those rules work out for us, and we are good to go. The last one we're going to talk about today, the quotient rule. This one's a big one too. And so quotient means dividing. And so I'm gonna do the same thing. I'm gonna expand these, see what it gives us, and then see what I get to do. And maybe let me just go through and expand all these. One, two, three, four, five, six. Need one more. And then here I'm going to be kind of stuck with these numbers. 5, 6, 7, and 8. Tough one there. And then 2, that's a crazy looking 2. 2, 3, 4, 5, 6. So now I have them expanded, and now we'll try to figure out what happens here. Well, a cool thing happens since I'm dividing, and I know that I have the same thing on the top and bottom. I get to cancel those out. That's cool. And what I'm left with is I'm just left with a 2. Okay. Well, I don't know how 2, 3, 2, 2 ends up just being 2. We'll have to figure that one out. Let's look at the next one, see if we can get any progress with that. So for every x on the bottom, since there's more on the top, for every one on the bottom, I get to cancel 1 on the top out. So I get to get rid of 3 of them. And how many am I left with? Maybe I'll circle them just so we can see how many there are, how many didn't cancel. Well, there's 4. Okay, and then on this one, I've got more on the top than on the bottom. But I do have a pretty close number. I get to cancel a lot of stuff out of this one. This is awesome. Okay, and what am I left with on the top and on the bottom? I have a 10 and a 2. Well, this is just 10 divided by 2. 10 divided by 2 is 5. So that's going to give me a 5. And then I have 2 x's left. Okay, I think we got it now. So at least in these two, it's pretty easy to see. How do I turn 7 and 3 into 4? Well, 7 minus 3 would be 4, just like 8 minus 6 would be 2. The numbers, I just had to deal with them as numbers. That's not any trick. And then, but this one, oh, that's right. This is 2 to the first. So 3 minus 2 would give me 1. All right, I think we got it. So the quotient rule is that if I have any number to the n over any number to the m, and the big thing here is that we're dividing, I want to go the power of the top minus the power of the bottom. And that'll be my way to simplify that. Go ahead and pause that and give that a try on these two problems. Okay, so for these ones, on the first one, you know, again, I just separate the numbers out, 7 and 35. Hopefully we know that that is equal to 1/5, or now that I say that, you're thinking, oh yeah, it is, okay. The x had nothing else with it, so I didn't get to subtract any powers of x's. I just get an x squared. It just has to stay with me. And then 5 times 5 is 0, so this would be y to the 0. But what is y to the 0? Anything to the 0 is always equal to 1. And I don't even have to write that 1 because I'm dealing with multiplication here. So really, 1/5 x squared is my answer. On the second one, I have 3 to the 5 minus 3, which is just going to be 3 squared. A to the 3 minus 2 is just going to be a, and b to the 5 minus 1 will be b to the 4th. Okay? And that's all we have today. Hopefully that kind of refreshes your memory on what we did in class, and hopefully you were able to follow along and pause and rewind as you needed. That being said, go out there, be great, have a good time, and we will see you in class.